In a game, two players take turns tossing a fair coin. The winner is the first one to toss a head. The probability that the player who makes the first toss wins the game is quarter, third, half, 2/3, or 3/4. Okay, so we can certainly rule out A, B, and C immediately because these are all less than or equal to a half, right? The player who makes the first toss has a 50% chance of winning instantly on the first toss. Now, if they don't, the second player may not win on their first toss, and so it comes back to the first player. So the options 1/4, 1/3, and 1/2, we can eliminate right away because the probability we need has to be strictly greater than a half. So it has to be 2/3 or 3/4. Now I happen to know I'm like 99% sure the answer is 2/3 here. But I think what we can do is write out a series that gives us the probability of winning. The probability of winning is going to be the probability that the first heads is on the first flip. So that's a half. Plus the probability that the first two flips are tails and the third is a head. That's this. Plus the probability that the first four are tail and the fifth is a head. That's this. And we just keep this going. So P is a sum. N goes from, how do I want to write this? 0 to infinity of 1/2 to the 3n plus 1. Or no, not 3n, 2n plus 1. Right? This is the probability that player 1 wins right away after one flip. If they win on the third flip, it means the first two flips are tails and the third is a head. So we need tail, tail, head. That has the probability 1/8. Or we need 4 tails followed by a head. So that's 5 flips with a certain outcome. It gives us this. Okay, so here I'm using the formula for a geometric series. And we get P is equal to 2/3. We probably could have ruled out 3/4 with a similar argument to how we ruled out A, B, and C. Right? 3/4 is the probability that the game ends on turn 1 or 2. Is there a nice way of seeing immediately that we can rule out 3/4? I mean, in some way, the player 1 winning has to be less likely than the game ending on turn 1 or 2. But and so maybe that's that's an argument for eliminating 3/4 immediately. But anyway, I've explicitly computed the probability. It's 2/3. I did know this basically right away because I did a computation like this in a video a long time ago, and it kind of stuck with me. So there you go. If I have more to say, I'll put it in the description. Thanks for watching.